Good morning. My name is Margherita Sini. I'm working for FAO, the Food and Agriculture Organization of the United Nations. I'm collaborating for 3 months with the IIT in Kanpur, the Indian Institute of Technology, for the agropedia project. We are here presenting today the agropedia indica project. Let's see in detail what is agropedia indica. Agropedia indica is a knowledge repository on agriculture of universal knowledge models and localized content for a variety of users with appropriate interfaces for different users, built in a collaborative mode and in multiple languages. We will see now in detail each of these steps to present which part of the project each of these elements are affecting. The first point is see what is the knowledge repository in agriculture. We would like to build a database with many types of different objects. It may be documents, it may be audio, videos related to agriculture. Each of these objects may be of different type and in different formats. For example, we may have documents which represent theses from students, white paper from researchers, and other type of documents like this, books or articles. We may also have other type of resources such as blogs, entries, so that people can post a question on a specific agricultural topic and somebody can reply to those questions. Or we may have forums. Universal knowledge models, because we would like to build a top-level knowledge models containing agricultural domain. For this, we would like to cover many different types of crops in which we have specific type of arguments. For example, production practices and post-production practices, which may be common for some crops, but may be specific for different type of crops, such as rice or mango or wheat. Cropping systems, which may also be common for specific crops or may be specific. Environmental information, such as climate or soil types, pest, disease, and nutrition information, which kind of nutrient can go for which type of crops, pesticides. So the first objective is to build a top-level knowledge model, including generic type of informations. Localized content means that for every specific type of crop, we may go more in detail and identify the characteristics which are specific for geographical areas, such as, for example, Indian states, or specific for varieties, or specific because we may have different trade names depending on the company who is producing different type of pesticides, for example. For a variety of users, we would like to build services which may help farmers, KVK scientists, village level workers like extension workers, or scientists, students, and policymakers. We may have, for example, resources that identify statistics on production of a specific type of crops. For each type of user, we would like to have specific services and specific interfaces. For example, for a scientist, we would like to navigate the knowledge model following the scientific names of the crops. So, for example, we may have something like rice, which may have a genus, and so on. We also would like to build interfaces in different languages. For example, this interface we may visualize in Hindi, which may be more familiar for farmers, for example. Another type of interface may visualize images for people that are less illiterate, for example, and we can identify visually which kind of concepts are connected to each other. Another type of visualization is a graphical visualization where there is less interaction with the map. All the map is presented in a unique image, so that people can immediately see the overall connection of the knowledge for a specific type of crops. For each of these interfaces, whatever the user decides to select, for example, rice, in the left panel of the screen, we may visualize the results of the search for this type of elements in the knowledge repository. So in this case, we may have as a result documents about rice, videos about production of rice, and so on. Agropedia Indica is a collaborative project. We have many different types of institutes collaborating together. IIT in Campus is mainly preparing the infrastructure of the system. Universities such as the Pant University, Harvard, and ICRISAT are mainly content providers. They will be dedicated to build the knowledge models for specific crops and provide the content for the knowledge repository. FAO, for which I'm representing here, will collaborate for the identification of the methodologies and the providing guidelines for the construction of knowledge models and the type of standard to use for the full projects. Other institutes such as IIT Bombay and IIT Kerala will also provide at the level of services and interfaces. Other elements such as KVK's expert may also provide for identifying which kind of services they need and provide further content. The final point is multilinguality. We would like to build Agropedia Indica in multiple languages. We will start with English, Hindi, and Telugu. Agropedia knowledge model will be covered for 70% with the Agrovoc thesaurus. Agrovoc is a multilingual agricultural thesaurus developed by FAO. If you want to see, this is the URL. And the translation of this 70% can be done automatically through this resource. Agrovoc is available today in 20 languages and more are coming, like Russian and Turkish. The other 30% will be translated through a local repository in Agropedia Indica, where all the terminology in different languages will be provided for translation of the knowledge models. Finally, just an introduction of services of Agropedia Indica. First of all, we would like to be able that user can navigate the concept map, the knowledge maps. As we mentioned, we may provide different kind of interfaces for navigation of those maps. The second important point is concept indexing. Today, indexing system traditionally use terminologies from a thesaurus, for example, for indexing. Agropedia Indica would like to build a service where the concept is associated to a document when we index. In this way, we are free for searching using any type of synonyms representing a concept, and we would have exactly the same result. Knowledge models will be also used for categorizing blogs elements, FAQ, and other elements of the project. Multilingual services. Through this idea of translating knowledge models in multiple languages, we also are free to find specific documents, no matter which language we use when we use our search. And finally, a very important point is problem solving. We would like to build a knowledge model and a specific infrastructure so that a specific type of questions that the farmers may have may be written in the system, and automatically they can get an answer.